Hi, and welcome to the very first episode of Koos Dev Talk. Koos Dev Talk is a weekly series where the three of us,
Parsa.
Jeffrey.
and myself, Justin, will talk about topics covering tech and dev. In today's episode, we'll be covering three topics. What is web components, and should you care to learn about them? Writing clean code versus technical debt. And finally, part one of what can AI do for you today? And so, Parsa, take it away.
Okay, thanks, Justin. So we're gonna talk about web components and should you care to learn. So web components came out exactly 10 years ago at 2011, and it was this promise of having separation of concerns within your code, having reusable code, being able to have future development, being future proof. And it was supposed to have all of those natively. And the way it was doing that was it gave us a JavaScript interface for us to create our own HTML element. I don't know why it's called web components. It's more like web elements. But the way it was set up was, and it still is that you actually inherit from the JavaScript class that HTML elements are made of, and then you can create your own element. And obviously, they had their own hierarchy of inheritance, so you don't have to go all the way up, and you can inherit from an element that you like, let's say an H2. But the problem was we started having all of these front-end libraries that did a bunch of things really good, and then there was no room for web components. Let's say where I use React most of the time, sometimes Angular, and React does a really good job of breaking down my code into different components and having a logical separation and a visual separation. So when I have all of that with React, also I have my state management, which is really important in today's web development. And I also have a subscription mechanism, which is kind of tied together with the state management, but subscription mechanism talks about and works with re-rendering stuff to the page without me as a developer having to manually do that. So I have all these great things within React and Angular and even Vue, and I'm sure a bunch of other things that I don't know about. And I kind of lose my interest in web components because it's giving me everything that web component gives me, plus a bunch of other things. So then I was researching all of that, and I went on to do some more research on why I should use web components. And I saw this on actually the React documentation where it says web components isn't meant to replace React, it's meant to work with it. Well, not just React, but any client-side library. And the claim here is web components gives us a way to separate our HTML logic, but since at the end of the day it's going to be pure HTML, we can use it inside our React applications. And I kind of that kind of hit me, and I made a blog post about it, and I showed how you can use web components inside React. But then the question becomes, why would I need web components when I have my separation of logic within my React setup? And it's actually more than a question, because if you think about it, having two way of doing your logical separation can be almost a disaster. So if you don't have a good plan if you don't have a good reason to start with to have both web components and a client-side library like React within the same project, I'm saying you're setting up yourself for failure, because you need a very good reason and a very, very good way of separating your logic when you have two way of doing it. So to answer the question, what is web component and should you care to learn? At this point in time, web component in my opinion, is not worth learning. But moving forward, I'm hoping to see some changes that make it actually useful when using with modern technologies in front end. That's my answer.
All right, thanks, Parsa. So I'll be here to talk about writing clean code versus managing technical debt. Writing clean code that is well structured and can be reused easily in the future iterations of your application. Clean code also makes it easier for other developers to understand what you are doing. So how does this relate to technical debt? Well, let's move on to what technical debt is. Technical debt is essentially extra work or code that you have to write in the future because of your actions. In this sense, the way you wrote your code or didn't write your code today. The reason why we are bringing up writing clean code versus managing technical debt is because you may find yourself in situations where you forego one over the other. For example, I had to create this registration feature in all the forms for a school project in a very short time as deliverables before the deadline, which was due. I had to make more robust more robust components for this form, causing me to write more code. And I guess that's what I'm getting at is you have to meet certain deadlines, and you may not be able to write the cleanest code and the most refined code without sacrificing your deliverables. But this creates technical debt, and you would have to revisit this code like I did in the future to iron it out and to really polish it out. So technical debt can be measured with time to market versus how much overtime you are working to pay off this interest. So before I wrap it up and hand it over to Justin, I would like to ask and leave you this thought of planning for technical debts, as they are sometimes unavoidable and you can recognize these as unintentional technical debt. So next I'll pass it to Justin.
Okay, thanks, Jeff. So on to part one of what can AI do for you today. So for part one, I'd like to actually talk about DALL-E, and DALL-E is a GPT-3 based model that creates images from text captions. And for those of you that don't know what GPT-3 is a language model, so it uses a similar machine learning algorithm or AI algorithm as Google uses for BERT, the one that lets Google infer context from your queries. And the difference between GPT-3 and BERT is that GPT-3 uses a much larger data set. GPT-3 uses mostly Common Crawl and Wikipedia, so in layman's terms, you can basically say that it kind of understands and learned from the internet. So what I wanted to do was to go over some examples of what DALL-E is able to do so that we can kind of showcase what AI can do for you today. And here are some images. So here we're going to read here that says the text prompt is an illustration of a baby daikon radish in a tutu walking a dog. And we can see here that it is a daikon radish wearing a tutu walking a dog. Even though some of these pictures may look more like white carrots or green carrots than a daikon radish, I think we can sort of get that it's doing the job, at least somewhat. And we can see that there's definitely a lot of different styles being used here. Thinking kind of like what the internet would tell you what a daikon radish cartoonized might look like. We can see like, okay, well, we can see a more kawaii daikon here, or something a little bit more strange, like maybe you'd see in a more mature cartoon. Let's move on to the next example. I really like the next one, and that is an armchair in the shape of an avocado. And the reason why I like this one a lot is because, again, the prompt doesn't really give much instruction. So a lot of the understanding has to be done by DALL-E in figuring out what the user that inputted the prompt wants. when we're asking for an armchair in the shape of an avocado, it knows that, okay, we're going to do an armchair in the shape of an avocado, but it doesn't really have context for how you might want it rendered. So when we look at a lot of these, there's a lot of variance. There's some that look like, cartoons or very clearly renderings, you could say. And then some other ones that look kind of like something you could imagine sitting in. It looks like a picture of a real chair shaped in an avocado, especially the one where I have my cursor on. If you look at that, it really looks like it's a soft cloth sofa. And so I just think that that's really, really interesting when we compare that to something more cartoony, like the third one, the middle one in the top row. I think you could agree that that looks a little bit more like, okay, that's a bit closer to like what you'd imagine a render would look like, as opposed to a picture of an actual product. Let's just go over one more. The third one is a storefront that has the word OpenAI written on it. Here, we can kind of see, like, not only is it, do all the pictures look more or less more realistic, which I think is an interesting choice that DALL-E makes. And it probably has to do with the word storefront, probably because when we maybe Google storefront, most of it are real pictures of actual stores that kind of makes sense. And so maybe it's leaning that way because of that. Maybe not. Maybe I'm completely wrong. Who knows? Only the researchers at OpenAI do. But I think another interesting thing is we can take a look at the fonts, and we see a lot of font variability. And a lot of these fonts, they do sort of look like OpenAI. Certainly, at least some of them spell out OpenAI, and some of them don't. Some of them have more interesting choices. So let's look at the middle in the top row. That's OpenAI, or maybe it's OpenLL or Open11. I think that that's interesting because we have to ask ourselves, did DALL-E make a mistake? Did DALL-E not write OpenAI by mistake, or did it write OpenAI or OpenBar on purpose? And when we look at all these font variabilities, I think it's interesting to think about the internet has a lot of fonts in them, and not every font may have an A that looks like what we would traditionally think of an A. One comes to mind is like a barcode. All barcodes have bars, and a barcode bar could represent an A. So is DALL-E making a mistake, or was it a choice? Is that what the internet told it that an A could possibly look like? Food for thought. Who knows? And so going back to the original question, what can AI do for you today? I think the first thing to take away is AI has come a long way, and it's coming a longer way extraordinarily quickly. And it will only continue to mature as time goes by. And when we looked at all these photos and examples, we kind of have to remember that these are not photos of actual things. They are randomly-ish, spontaneously generated as instructed by the AI's model. And so it's when we think how could that help us? What could it help us with? I think a very easy example is, suppose you're an entrepreneur or a company owner or something, and you wanted to make a new product, and say you wanted to make an avocado chair, and maybe you had a slight idea as to what an avocado chair might want to look like, but maybe not quite. And so maybe you ask DALL-E or ask another AI model, hey, I wonder what would look nice. And then all of a sudden you could have, almost 1,000 different renders of what an avocado chair looks like. And you could kind of look at the output and then kind of get a jump start. Say, oh, hey, I kind of like parts of this design, or I kind of like that design completely. And it could give you a jump start to creating a product or creating a real product or at least an idea. And I'd probably go farther saying if you have access to Dolly, maybe you have access to something else too. Maybe you create the product from the image and then you have another model that can read the image and then create a 3D, blueprint for it or something like that. So I think there's a lot that AI can do. And so that will do it for part 1 of What Can AI Do For You Today. That's a wrap, everyone, for the first episode of Koos Dev Talk. Parsa and Jeff, do you have any words for our audience?
Thanks for watching. Make sure you give us a subscribe wherever you get your podcast.
Thank you so much. See you next time.